All right. Can everybody hear me okay? Great. Welcome to Strongly Typed CSS with Vanilla Extract. Now this talk is mostly going to be about CSS, but I actually want, sorry, there's a bit of a delay in between. Nope, all right, we'll roll with it. That's great. Now this talk is going to focus mostly on CSS, but I actually want to start up by talking about JavaScript. I really think we're in the golden age of JavaScript right now. We have all these tools in our IDE in terms of ESLint to help us prevent any kind of errors, and Prettier to help enforce a lot of style standards. We also have like all our TypeScript to help us enforce type safety. And now with tools like Next and Remix, I think we're really in the golden age in terms of JavaScript, in terms of performance as well. I think it actually might be kind of hard not to write performant, scalable, maintainable JavaScript applications using all the tools that we have at hand these days. That is until you have to write CSS. When I write CSS, I kind of feel like I have to have a crystal ball to be able to read the minds of all the developers that wrote CSS of my application before me, as well as every designer that will reskin my application in the future. I still remember back when I was a junior developer, I would always have these two senior developers on my team arguing over their interpretation of BEM in my pull requests. Super weird spot to be in. Now, I think this is largely because we haven't found this kind of tooling that we have with our JavaScript. We still haven't found a way to write maintainable, performant, refactorable CSS. So what we're going to do today, we're going to look at a lot of the common approaches to CSS out there today. We'll go over the pros and cons of each. We'll dream of our pie-in-the-sky approach to CSS, and then we'll see how Vanilla Extract approaches solving these problems. But first, a little bit about me. I'm Georgia Loper. You can find me online at Developer Loper. If we're all still using Twitter, you can find me there, mostly retweeting the Storybook account. I've worked at kind of the gamut of different kinds of front-end applications. I've worked at large enterprises, tiny startups. I've worked on everything from legacy systems to static landing pages, spas, and kind of the array of different hybrid approaches we have to delivering web applications today. Currently, I work on the design system at Upstart, and what I'm going to be talking about today is our approach that we use on our Patina component library. This will be the only picture of slides you have to take today. This will link to my GitHub, where these slides will be, as well as a little demo application that has all the code, that I pulled all the code from that we'll be looking at today. I'll have this up again on the last slide. It's also in the Discord channel for this session. This is the interface we're going to be looking at implementing today. Pretty simple. We'll be aiming for this markup where we have a root div and an h1 with some content. These are our base set of styles we'll be implementing. We'll just have a navy background color, a plum colored text, and some padding. We'll encapsulate this markup in CSS into a heading component, which will be used in our parent app.tsx component like this with no props initially. But then we might expand on that implementation to be able to take some props as tokens. So here we have secondary, primary, and medium tokens used rather than the hard-coded direct values. We'll go as far as theming with CSS variables. The application that I work on that I need to support, I have to support a lot of theming, not just like a handful or a couple of themes. I have to support dozens or in the future hundreds of themes, and it's really impractical to define all my themes all at once and send all those themes to the browser. So we'll really have to rely on CSS variables to swap out themes at runtime. So what approaches to CSS are we going to be evaluating? We'll look at the state of CSS 2022. This was released about 4 months ago, and they largely bucket approaches to CSS into 2 categories: CSS frameworks and CSS-in-JS. As far as CSS frameworks, Bootstrap remains ever present, but far and away the most common approach to styling with CSS frameworks today is Tailwind. Now, Tailwind is really just a flavor of atomic CSS, where generally one class styles very few, usually one CSS properties. But we'll just look at atomic CSS generally, not specifically Tailwind, because this approach is used like really everywhere. If you've ever applied like margin or padding using a framework like Bulma or Bootstrap, you've used atomic CSS. You've probably written your own atomic CSS classes or used atomic CSS classes written by somebody on your team. We'll also look at CSS-in-JS. Right now, the most common approach to CSS-in-JS is CSS modules. So common, it actually shipped out of the box with Next.js for a while. Lots of frameworks like Remix also support really easy setup for CSS modules. And CSS is actually a build time CSS is in JS implementation, as well as vanilla extract. But largely, CSS in JS libraries are runtime that includes like emotion, styled components, JSS. So we'll bucket those into their like their own approach, runtime CSS in JS. So what is runtime CSS in JS? What do I mean by that? Runtime CSS in JS allows you to author your styles in your JavaScript or TypeScript files, and then those styles will be interpreted and applied to your elements in the browser at runtime. Okay, what does that mean? What does that look like? This example is using emotion React. You could see we have this CSS prop that is applied to our div element. Emotion and other libraries have like a build step that you have to implement that adds either this CSS prop to all your elements and components, or you might import a CSS function. Regardless if you use a prop or a function, you'll supply a block that represents the styles that you want to apply to your element. You can see how this approach really lends itself to using props or state in your component to influence your styles. See here, we've surfaced our background color and padding as props to the component, and then we're piping all those right through to our CSS prop. This is the CSS that you'd see in your browser. You can see it has the literal string CSS followed by some hash. So this is the class that is generated, and then that prop or function will return this class and apply that to the class attribute of the element. So the really nice thing about having hash classes is it really makes sure that that class only applies and affects the element that that class is applied to. You don't have to fight the global scope in case you have, like, I think we've all experienced, like, having a class and not knowing about that class and writing the same class name somewhere else, and then you have the collision just due to the nature of the global scope of CSS. So the pros of Runtime CSS-in-JS include that developer experience. It's really nice to be able to use props and state to influence our styles without having to inline styles. We all know that inlining styles isn't optimal when we're applying a lot of the same styles to multiple elements. We also have good co-location of our styles and the components. Co-location is generally good so that when code that works together gets deleted together. In CSS-in-JS specifically, we know we won't have any dead CSS classes hanging around our application because all of our CSS classes are generated in the components. So if those components are deleted, obviously we can't, obviously those CSS classes won't be hanging around. We have their locally scoped classes with those hashes. And this implementation can be made type safe just depending on which libraries we're using and how we ultimately go about implementing all these. Now the cons of Runtime CSS-in-JS are pretty severe. There's that runtime overhead. Turns out it's pretty expensive to be generating CSS classes in the browser, especially when you have like hundreds or thousands of elements that you're styling. There's a lot of complexity to implement server-side rendering since the classes are generated in the browser. When you server-side render these elements, it's non-trivial to avoid layout shift. And bundle size, since you're shipping these libraries to the browser to perform these style generations, that means like you have to have that extra JavaScript that you're sending to your users, so it kind of bloats your bundle. If you want to dig into more details about this, about the cons of CSS-in-JS, highly recommend this article that was circling around late last year. Note that it does clump vanilla extract in with these runtime CSS-in-JS libraries, but fortunately after today, you'll be the experts in vanilla extract, and you could spot all the places this article gets it wrong. All right, let's talk about atomic CSS. Atomic CSS, again, is where one class styles very few, usually one CSS properties. All these classes are then composed together in your markup instead of just writing more and more CSS. You kind of write all your CSS at once and then just focus on writing your markup. Since Tailwind is the most common approach today to atomic CSS, all these examples actually will be in Tailwind. This is what our heading component we've been looking at would be like. You can see we have one class for our background primary style, one class for our secondary text style. I'll apply that plum color. And then we have our padding class. This is the CSS you would see applied to that element in the browser. Note that this will be a static CSS file. We won't be doing any generation like with Runtime CSS-in-JS. Do note that these classes are not hashed, though. We can even take it a little bit farther depending on our implementation. We can have, instead of directly hard-coding the values in these classes, we can have them reference CSS variables. So that allows us to swap out these values, the values of these CSS variables at runtime to be able to swap out our themes. This is what it would look like if we wanted to use props to influence our search styles. We'll surface our background, color, and space props on our component. Since we're composing together a lot of props, we'll probably implement some library that will basically just join all the strings of these classes and add separate by them strings, separate them with spaces. And then we'll probably be maintaining like a bunch of maps to map the token that we want our parent component to pass in to the ultimate class that we want to supply to the element. Because the whole idea of components is that we want to abstract away having to remember our classes or having to remember like what specific colors we want to be able to apply to our opinionated components. So that means we end up maintaining all of these maps where we have our tokens, and then we have to assign them to the classes that we have, and then we have to keep these up to date, whatever classes we might be creating or deleting. Tailwind has like some plugins in your IDEs and some CLI helpers to generate these maps, but you can't actually use that IDE feedback in your code. So you actually have to go and make those changes manually to keep up with what classes ultimately exist. So the pros of Atomic CSS are that there is a finite of CSS that you'll ever have in your application. You'll create all the styles, all the classes you think you'll ever need, and then reuse those everywhere. And that allows us to stop inventing class names, remembering some arbitrary naming scheme. We all know that naming is the hardest part of our jobs, so this is really, really helpful. We have a static style sheet, so we get all the performance benefits that we lose when we use Runtime CSS-in-JS. We have a small bundle size because we don't need to ship any JavaScript to the browser to be able to run our styles. And some people think that this helps us refactor and do redesigns with safety, because we wouldn't actually be changing our CSS. We'd actually do redesigns by going in and changing which classes are being applied in our markup. I don't necessarily agree with this pro. If I have a tokenized style system using CSS variables, I would expect retheming to be a lot easier than having to go in and touch all of my markup. The cons of Atomic CSS are that you're dealing with the global scope. So if you have like an injected cookie consent banner, or if you're working on a micro front end where another team might be adding CSS and components to your page, you might be getting collisions if you have some classes that are similarly named, and that would just come down to which style sheet got to the browser first to control which takes priority in the cascade. You have the mental overhead of learning and remembering all of the styles and classes that exist. A lot of times, like Tailwind will have plugins in your IDE to help you with this, but you often find you have the framework's doc site pulled up every time you're styling anything. That developer experience isn't the best. Like I said, we have to have some maps and be doing a lot of extra code to be able to use props and state to influence our styles. And some people don't really think that this lends itself to very readable code. They don't like that all the classes clutter up the markup. I'm not sure if this is really something I'm too concerned about. If we really consider the browser as a compilation target, then we really shouldn't be too concerned about cluttering up the DOM. All right, let's talk about CSS modules. CSS modules are hallmarked by their CSS-like syntax, but it's actually build time CSS in JS. This is what it would look like to build out our base styles with CSS modules. We have our heading.module.scss file, and you can see that this looks just like regular CSS. Then in our heading component, we'll import our styles from that module.scss file, just like we would any other JavaScript module. And then we'll key off our root style from that styles module. So if you look at this, this is really just like JavaScript as far as its behavior in our JavaScript component file. This is the class that would ultimately be passed down to the browser. And so this is build time CSS-in-JS. This would actually be in a static style sheet. This wouldn't be generated, but we still get that hash, so we're not interfering with the global scope. So the pros of CSS modules include, we have that hash, locally scoping our classes. We know that the classes will only affect the component that they're explicitly applied to. We have explicit dependencies. Since we need to import our CSS into the specific component files that's being used, we know exactly where all of our CSS classes are being used, so that at build time, we could tree shake any CSS classes that aren't used in the components on the page. And we have these import maps that allow us to delete module.css files that aren't being used. And it has the familiar syntax that just looks just like writing CSS. The cons of CSS modules include developer experience. There's really no clear way to surface our styles as props and use props and styles to influence our styles. Props and state to influence our styles. Oftentimes, you find that when you're using CSS modules, you're still maintaining a set of atomic CSS classes to be able to use those tokens and pass them around our components instead of the direct values. Or you end up restyling a lot of the same properties with a lot of the same values in all of your CSS module classes. There's no real way to implement runtime theming. Since we're using CSS, it'll all be compiled down to the hard-coded values in the classes. So if we wanted to use CSS variables, we'd have to maintain a CSS variable layer in addition to our Sass variable layers that we're using in our CSS modules. And we don't have type safety. There's just really no way to go about that. So what would our pie-in-the-sky approach to styling would be if we could combine the pros of all the approaches that we just looked at? Well, we'd want performance, super important for users. We want developer experience. We want to be able to smoothly use props and state in our JavaScript code to be able to influence our styles. We want scope styles. We don't want to be worried about collisions in the global scope. We want type safety. We want to be able to author, delete, and refactor our code with confidence. And we want runtime theming. May or may not be a requirement, depending on your context. Certainly is a requirement for component libraries that we support theming. And we want to have some degree of atomic styles. We do like those benefits that we gained from a finite style sheet and not having to reinvent class names. And of course, we want to avoid naming as much as possible. So let's look at how Vanilla Extract approaches solving these problems. Now, Vanilla Extract's doc site says Vanilla Extract is a 0 runtime style sheets in TypeScript. Use TypeScript as your preprocessor, write type-safe, locally scoped styles, variables, and themes, then generate static CSS files at build time. Well, that's a lot of buzzwords, yeah. What does that actually mean? It's a little bit hard to talk about these concepts in the abstract, so let's look at some implementation. Since Vanilla Extract runs at build time, it does require integration with your build system, has support for lots of different bundlers. And Vanilla Extract is ultimately a library, actually a set of libraries that export some functions and types and help and helpers. The most common function, kind of the most basic implementation, is this style function. This style function creates a style rule with locally scoped class name. All right, what does that mean? How do we use that? Let's jump in here. We'll create a heading.css.ts file that will live next to our heading component. Now this .css.ts extension is super important in Vanilla Extract. This is what tells our build plugin to take this TypeScript file and convert it into static CSS at build time. So anything that is written in the .css.ts file will be executed at build time. Anything that's in a .ts file or .tsx file will be happening at runtime. So it helps draw that clear mental distinction. So we'll go ahead and import our style function from Vanilla Extract CSS. We'll define a root const that will assign to the result of that style function, and to that we'll supply as a parameter our block containing the styles that we want to apply. And this is all written in TypeScript, so we get all the TypeScript help that we're used to in our IDE. If we hover over a property, we'll be able to get that popover, giving us more information about that property, since Vanilla Extract is built on a CSS types library under the hood. And if we misspell something or try to style a property that doesn't exist, or who knows what we're doing, we'll get that TypeScript red squiggly telling us, hey, go check your spelling. Super important for me because I might actually be the world's worst speller. So then if we go into our heading component file, we'll import our styles. Note that we're importing this from a just .css, not css.ts. This is just like the convention that we have to follow. Note that there is no actual .css file on disk at this point. We'll then key off our styles module to get our root const that we defined. Now, notice that this looks like exactly like our CSS modules implementation. This is no coincidence. The CSS modules co-creator is actually the Vanilla Extract creator, so a lot of this is written from the same perspective. Since this is all just JavaScript, we can also destructure our root const from the styles module and supply that without having to do that object chaining to apply our root class to our class name. There we have our base styles applied to our component. And this is the CSS that we'll see in the browser. So this is all compiled at build time because it was written in a .css.ts file. And we'll actually see different output depending on if we're running in dev or we're running in prod build mode. You can see in dev, we actually have some debug class helpers. We have, which will be the name of the file that our style was defined in, the name of the const that the return of the style function was supplied to, and then you could see we have our hash to scope that class to wherever it's being used. Now in prod, we'll just get that hash. Now it's important to note that the last character will just increment for every style rule in that file. So if we're creating multiple style rules in a lot of the same files, we can actually run everything through like gzip and get our DOM down pretty small. So let's go back to our heading.css.ts file. And one thing that's important to call out about Vanilla Extract is that it's not quite like CSS modules in that the syntax can be somewhat different from regular CSS. For instance, to use any selectors like pseudo selectors or hover or anything like that, you have to use this selectors key. Now, Vanilla Extract is opinionated in that selectors can only target the element that this class is supplied to. So they do that by enforcing that everything you target starts with the and selector character. So vanilla extract can tend to be pretty opinionated. I find that it's helpful that they can impart the knowledge that they've learned from building component libraries and CSS to help us write maintainable code without necessarily having to make the same mistakes and same experiences that they had. But they don't leave you completely hanging if you need to use more complex selectors or break their kind of opinionated ways of doing things that they're enforcing on things like the style rule. They also have this global style function that creates styles attached to a global selector. So let's look at that looks like. Here we have a global.css.ts file. We'll import global style from vanilla extract CSS. And we'll call the global style function with the first param being the selector that we want to target, and then our second param will be our style block. And we could see that creates CSS that would look like this. So this is super great for doing our global CSS reset. Also, we could go back to our file and do some things that are a little bit more complicated, like if we wanted to import our style function. And now that style function just takes a block and creates a CSS class that renders the styles represented in that block. So we can pass it an empty object and just get a hashed class back. And then we could go ahead and use that const and in our global styles selector and target that hashed class and our global styles. So this is the hash. This is the class that would create. We could go into our root app parent component, import that root class, and supply it to the root of our application. And all links that are children of this element will be styled with that CSS that we defined in our global styles. Now we could do this anywhere. Here we're doing it at the root of our application, so all links would be that navy color we defined, but we can apply this class on just a particular component or just a section of the page to just target children of wherever this root class is applied. Now, between the style function and the global style function, you can do basically everything you can with CSS and all the frameworks and approaches we've been looking at so far. So this is where vanilla extract will really start to separate itself. Let's look at the style variance function that vanilla extract supplies. Now this creates a collection of named style rules. What does that mean? We'll go back in our heading.css.ts file. We'll import this function, and instead of defining root, we'll define some variance const that will be assigned to the return of the style variance function. And in that first param, we'll define a primary key and supply a block representing the styles we want supplied to our primary variant. We'll do the same for a secondary variant, where we'll reverse the colors that we're supplying to our background and color property. So this is all in TypeScript. We'll go ahead and take that variant and import it into our heading component. And we can actually add a variant prop to our heading component. And then we'll use that prop to key which variant off of that variance const that we want. So that allows us to go into our parent component and supply variant primary to our heading component, and that will supply our primary class, or we could supply our secondary key to the variant prop, and we'll get those inverse styles that we defined for the secondary variant. Now, what's really cool about this is since this is all in TypeScript, we can define our variant heading props using key of, type of, variants. And then if we try to supply like some variant that doesn't exist, we'll get that TypeScript feedback like, hey, you could only use primary or secondary here, or you spelled something wrong. Again, super important, has saved me quite a bit. What's also cool about this is if we were to add like a tertiary key to that variance block, that would just automatically be part of the type of our variant prop on our heading component. We wouldn't actually have to go in and change our component at all. It would just become available as a prop that we could pass from our parent app component. One thing, going back to our heading.css.ts file that I'm not a huge fan of, is that I'm repeating this padding value in both my variants, even though it's just the same value. So let's see what we could do about that. We've already imported our style variants. We could go ahead and also import our style function. We'll create a space const that just applies that padding. And then if we go down to our primary key, instead of just supplying that object, we'll supply an array that composes together that space const as well as an object with the styles that are specific to our primary variant. We'll do the same with our secondary variant. And now the only difference in these primary and secondary is what is actually styled differently between the variants. So these are the classes that would be supplied to my primary variant. You can see I have one class that is just for those two properties that are specific to my primary variant. And I have a separate class for my space, to apply my space. So we can infer that having that array in the style variant is actually going to compose together separate classes for everything that's in that array, rather than just duplicating and adding in that padding back into my primary class. So that padding property in my primary class. So if I have multiple elements, they'll all reuse that same primary class, and I'll have less duplication of properties. Now, one thing that I'm still not a huge fan of in this .css.ts file is that I'm hard coding all my values in here. So let's see what we can do about that. Vanilla Extract has several helpers and functions that they can that they export to help with theming. We'll just look at a couple of the most kind of basic approaches to that today. They have this create global theme function that creates a theme attached to a global selector, but with locally scoped variable names. So let's see how to use that. We'll create a theme.css.ts file, import that function, and we'll create a vars const. Vars is kind of like an arbitrary name, but it's kind of taken hold as a standard in the Vanilla Extract community because it is actually returned by this create global theme function is an object representing a set of CSS selectors. So this vars will be like this object that we define, but when we actually go and look at the browser, we'll have a set of CSS variables that map to those in this object. So in that object, we'll, just for some organization, we'll create a color key where we'll tokenize our color values into primary and secondary keys. And we'll do the same and create some small, medium, and large space tokens. this will be the static CSS. You can see we have some CSS variables that are assigned to the selector that we defined in the, that we pass as the first param to that function. You can see we have two CSS variables for our colors, and we have a CSS variable for each of the space tokens we defined. So now we could go into our .css.ts file. We can import our vars, and then instead of hard coding like our padding value, we can key off our vars object to a token that maps to that value that we want to apply. We'll do the same to our background and color properties. And now this is the CSS that we'll see applied to our primary variant. You see we have, instead of hard coding our values, they're referencing those CSS variables that are on the root selector. Now this is just going to create one theme. Oftentimes you'll need to support multiple themes. So there's kind of this like next step of the theming implementation would be using this create theme function. This creates a locally scoped theme class and a theme contract, which can be consumed within your styles. So what this means is if we could call create theme twice and supplying two separate theme-specific classes, TypeScript will impose that we follow that same vars object structure for both themes. And this will ensure that when we key off that vars object, a value for that ultimate CSS variable will always exist regardless of which theme we're in. So these, if we were to call that create theme function twice, once with a theme A class and some values specific for that theme, and again for theme B, we would get both of these sets of CSS variables generated, and then we could swap between themes by changing out these theme classes at the root of our DOM tree. Now that's great if you have just a couple of themes. Maybe you have like a light mode and dark mode theme. Again, I have to maintain or support dozens or hundreds of themes, so it's not really realistic to maintain all of those in my create theme files like that. Luckily, Vanilla Extract offers this dynamic package that allows for performing dynamic updates to scoped theme variables. Cool. What does that look like? Well, I'll first go back into my app.tsx parent component. I'll import this as assign inline vars function from Vanilla Extract dynamic. I'll import my vars from my theme file, and in my root, I'll call the assign inline vars, supplying my vars as the first parameter, and then TypeScript will help me ensure that I supply an object that matches the structure of my vars, but has my new values for the new theme that I want to swap the current CSS variables out with. So with all that, what we've seen so far from Vanilla Extract, what have we benefited? We have performance. We have a static CSS style sheet. We have developer experience. We can very easily use props and state to influence our styles. We have scope styles with those hashed classes. We have type safety, since everything is in TypeScript. We have runtime theming with assign inline vars. What can we do about atomic styles? How do we prevent ourselves from having to rename all these classes in our heading.css.ts files all the time? Well, Vanilla Extract offers this sprinkles function This is a zero runtime atomic CSS framework for vanilla extract. Generate a static set of custom utility classes and compose them either statically at build time or dynamically at runtime without the usual style generation overhead of CSS-in-JS. Basically, it's like building your own zero runtime, type-safe version of Tailwind styled system, etc. Now that sounds exactly like what we want. How do we go about implementing that? Well, first we'll create this sprinkles.css.ts file. Now this code looks pretty intimidating, but we'll go through it and we'll see that it's actually just a lot of boilerplate. So first, we'll import defined properties and create sprinkles from vanilla extract sprinkles. We'll define a properties const that will be assigned to the return of defined properties. And then we have these conditions key that we can define media queries for each of our different conditions we want to target, being mobile, tablet, and desktop. But actually, in the case of mobile, we won't define a media query and actually set that as our default condition. So this will help us do a mobile-first approach to styling. From there, we'll import our vars const, and we'll have this properties key where for every CSS property we want to create atomic CSS classes for. We could assign a kind of like a piece of our vars. So we need to, if, for example, we want our color and background to be able to be any of our keys in our vars.color object, and we want our padding property to be styled with any of the keys in our vars.space object. So from there, we'll create a sprinkles function that will assign to the return of create sprinkles, to which we'll pass those properties we defined. Again, this is a lot of boilerplate. Really, all we need to focus on in here is defining which conditions we want to target with media queries and defining which properties we want to create atomic CSS classes for. This is the static CSS that would be generated. You see we have classes for each of our colors. We have classes that target the background property with the same vars values. And then we have a different class for each of our spacing values. Now, if we notice the name of the classes that are being generated, we have the name of the file, the name of the property, the name of the key from our vars for that property, and then we have our condition mobile. So we can infer that we have our mobile classes, but we're also generating a set of tablet classes that are scoped to the tablet media query, and we have a set of desktop classes that are scoped to the desktop media query. And you could see one thing that I'm not a huge fan of already is that we're just supplying padding just generally. So that means that any element that receives these classes will get the same padding value on each side of that element. We probably want a little bit more control over our spacing than that. So let's see what we could do. We'll go back to our sprinkles properties, and instead of just supplying our vars space to padding, we'll supply it to each of padding top, padding bottom, padding left, and padding right separately. And then we'll add this shorthands key, and we could define any number of shorthands as keys in this, and that could be assigned to an array of the classes we wanted to we want to compose together when we use that shorthand. So if we use the padding shorthand, it'll supply all of the top, bottom, left, and right padding classes. Same if we use the padding X or padding Y shorthands, it will supply padding left and padding right, or padding top and padding bottom classes respectively. So if we go into our heading.css.ts file, I've trimmed this back to just focus on our base set of styles. We'll go ahead and import our sprinkles function. We'll define our root const that will assign to the return of our style function. But in this time instead of supplying an object in the param, we'll supply an array. And in that array, we'll have our sprinkles function, to which we'll supply an object that represents the styles we want to apply to represent our primary variant. So notice instead of referencing our vars or hard coding a value, I'm actually using strings of the key of the vars for each property that I've defined that I want to apply to that property. So this is the CSS set of classes that would be applied to our roots const there. You can see we have our background and color class, and we have a different class for each primary or padding right, left, bottom, and top. Now, if we wanted to just have some padding on the left and right, we can use that padding X shorthand that we defined, and that will just supply our padding right and padding left atomic CSS classes. Now, what's really cool is if we wanted to just style the left padding, but we wanted that to change at each breakpoint, we can actually define what we'll call this media query object and define a different token for each of our breakpoints, mobile, tablet, and desktop. So that would supply our mobile padding left atomic CSS class, as well as our tablet class, as well as our desktop class, and it will reference the different CSS variables at each breakpoint appropriately. Now what's cool is these classes are, again, created statically at build time, and it's not like directly correlated to our component. So that means that we can reference these classes in any component. We don't necessarily just have to reference them in .css.ts classes since they're already generated. So we could go ahead and delete our heading.css.ts file. We could import our sprinkles function, and we can call our sprinkles function right there in our component, supplying that same set of styles, that same representative style object that we want to supply. Now we could lean further into kind of the CSS-in-JS style development or developer experience that we're starting to see here. We could go back into our sprinkles.css.ts file. We'll create a type called sprinkles from our sprinkles function that will type the parameters that we can supply to that function. We'll import that into our heading component, and we'll use that type to type each of the background color and padding props we want to expose in our heading component. We'll expose those as props and use that type on our heading component. And then we could pipe whatever is passed in from our parent component directly through to our sprinkles function to supply those atomic CSS classes. Now this is pretty cool. What I don't love is that now our heading component is pretty tightly bound with our sprinkles styling implementation. So let's see what we could do to abstract that. Material UI is a really popular component library you might be familiar with. They have this concept of a box component, which is really like a wildcard component that binds any element you want it to be with the MUI styling implementation. Chakra has a similar kind of concept. It's something that we're seeing a lot out there these days. This is an example of what a vanilla extract flavored box component would be like. We'll import our sprinkles function and our sprinkles type. We'll expose a prop that can accept any valid DOM element. By default, we'll have it render a div. We'll expose a sprinkles prop that is typed to our sprinkles, and we'll expose some child node, and then we'll render whatever DOM element was supplied and call our sprinkles function with whatever sprinkles object was supplied. So this is like kind of complex, kind of like a weird thing to do. This is really just a fancy way of rendering a DOM element with some classes. But then we could take that element into our heading component, and we can use that to supply our background color and padding from our parent component to that sprinkles prop on our box component. And now we've abstracted our styling implementation to the box out of our component. Now, all of our other components that we make that use the box can use that same set of atomic CSS classes we're generating in our sprinkles without having to also be bound to the specific styles implementation just by using the box sprinkles prop. You don't even have to write your own box component if you're using vanilla extract. There's this cool dessert box project out there that does all this for you. So now we have that nice performance that we seek with static CSS. We have that nice developer experience since we can use props and state to influence our styles. We have scope styles with hash classes. We have type safety with TypeScript. We have runtime theming with vars and CSS variables. And we have atomic styles. We have a finite, highly reusable set of classes. It's not all roses. We do have some drawbacks. There is no way to purge all of those classes that we're generating, which is something you might be familiar with if you use Tailwind. They have a purge plugin that will remove any classes that aren't used on that page. There is a PR open against vanilla extract right now to add that ability to their Vite plugin. Hopefully we can see that get merged soon and be also offered on all their other plugins. Right now, the solution to this is to be a little discerning about what atomic CSS classes we're creating and only create those for the most common properties and values we're assigning, rather than in Tailwind. We create classes for everything under the sun we can think of. I really only use it for properties that will be styled the same way, multiple times. I still use .css, .ts files for kind of more idiosyncratic styles. I also can use multiple defined properties if I have properties that I know I want to style that won't be different across my various conditions. I could just generate those for with no media queries, so kind of reduce the amount of classes being generated by 1/3. Other drawback to vanilla extract right now, there's no way to do dynamic inline style assignments. If you're familiar with Tailwind, they have a special syntax that allows you to effectively define any value that you want to be applied to some property for values that, or properties that might not be heavily tokenized, like like your width, your height properties. There is this really interesting project by Wayfair that does just this exact thing. So hopefully we can look for them to contribute back to vanilla extract with that capability in the future. So today we saw how we can use vanilla extract to create highly reusable, type-safe, locally scoped styles implementation. As you can see, it's a fairly complex setup, so it's probably not the best choice for like personal projects or small sites. But hopefully you saw how this could be used to allow teams to move quickly with confidence and maintain larger applications or component libraries. Thank you.